The unlikely beginning. In 1993, one of the most consequential technology stories began in an unlikely place, a Denny's booth. Three engineers sat down with a simple but radical belief. The future of computing would be shaped by graphics. Jensen Huang's vision. At the center of that vision was Jensen Huang. He believed computers could do more than process numbers. They could create visual worlds, simulate reality, and eventually transform the way people interacted with technology. The graphics problem. But in the early 1990s, computer graphics were still heavily constrained. Games were growing rapidly, yet realistic three-dimensional experiences required far more computational power than ordinary processors could efficiently provide. Thinking from first principles. So, they approached the problem from first principles. Instead of asking what existing computers could do, they asked a different question. What if a processor were designed specifically to handle the enormous workload of graphics? Imagining 3D worlds. That question opened a much bigger possibility. Imagine computers capable of rendering immersive three-dimensional worlds in real time, worlds where games, simulations, design, and visual computing could become dramatically more realistic. Three engineers at a diner. Jensen Huang, Chris Malachowski, and Curtis Preem began shaping that vision together. Their headquarters wasn't a polished technology campus. It was a booth at Denny's in San Jose, where ideas were discussed over coffee and handwritten notes. From conversation to architecture. The conversations quickly moved from ambition to engineering. They discussed processor architecture, graphics pipelines, and how to build hardware capable of processing many calculations simultaneously. The idea was becoming an actual technical blueprint. The founding agreement. In 1993, the founders formalized their plans and launched what would become NVIDIA. They weren't simply creating another semiconductor company. They were making a long-term bet that accelerated graphics could become a fundamental part of computing. A bet without guarantees. There was no guarantee the market would agree with them. They had limited resources, enormous technical challenges, and a future that had not yet arrived. What they possessed was something harder to measure: conviction in an idea. Turning the idea into silicon. But conviction alone couldn't build a processor. The next step was execution. Turning architectural ideas into silicon. Every circuit, every design decision, and every engineering problem had to move the vision closer to reality. The bigger bet. For Jensen, the opportunity was bigger than winning the video game market. The deeper bet was that graphics processing could become a new form of accelerated computing, powering applications far beyond what anyone could see in 1993. When the vision started to work. As graphics hardware advanced, the original thesis became increasingly compelling. Three-dimensional computing was no longer just an idea on paper. It was becoming a practical technology capable of changing what computers could display and calculate. From gaming to computing. And then something bigger happened. Graphics processors began finding uses far beyond gaming. Visualization, scientific computing, simulation, and eventually artificial intelligence all benefited from the same fundamental idea. Massive amounts of computation could happen in parallel. The Denny's lesson. The Denny's story reveals 4 powerful lessons. Start with first principles. Solve a meaningful problem. Be willing to believe before the crowd does. And most importantly, execute relentlessly when the idea meets reality. The legacy. What began as a conversation between 3 engineers eventually became a defining chapter in modern computing. The original bet on graphics helped NVIDIA evolve from a startup focused on visual computing into a company at the center of the accelerated computing era. Big ideas can come from anywhere. The real lesson isn't that NVIDIA started at a diner. It's that transformative ideas don't always begin in extraordinary places. Sometimes they begin with 3 people, 1 difficult problem, and the courage to imagine what computing could become. Why graphics mattered. The founders understood something important. Graphics weren't simply about making games look better. They represented a completely different way of using computational power, one that could eventually reshape the entire computer industry. The hardware challenge. The vision was ambitious, but the engineering challenge was enormous. Building specialized graphics hardware meant solving difficult problems in architecture, circuitry, performance, manufacturing, and cost, all at the same time. The startup reality. Behind the big vision was the less glamorous reality of startup life. Long hours, limited resources, technical setbacks, and constant decisions about where to spend time, money, and engineering effort. The first product bet. Eventually, the idea had to become a product. The company couldn't survive on a compelling philosophy alone. Its technology needed to work, reach customers, and prove that the market was ready for a new approach to graphics. The market test. Now came the real test. NVIDIA had to convince customers, developers, and the broader industry that specialized graphics processing wasn't a niche experiment, but the beginning of a much larger computing opportunity. Learning from setbacks. The journey wasn't perfectly linear. Hardware development brought setbacks and difficult choices. But those challenges reinforced a crucial principle. Ambitious technology companies have to learn quickly, adapt, and keep moving when the original plan doesn't work. The idea gets bigger. The deeper insight was becoming clearer. If one processor could accelerate graphics, the same principle could accelerate other forms of computation. The opportunity was beginning to look much larger than the founders originally imagined. The founding idea lives on. What started as a conversation around a diner table became a long-term technological bet. The lasting lesson is simple. When you identify a fundamental shift early enough, a small idea can become the foundation for something much bigger.